Hello, Algebra 2 Honor students. We are here going to do the review. I'm going to try this on doing Microsoft Word instead of a notebook file, so I don't know how it's going to work. I might get a little frustrated a couple times because you know technology loves me and always does what I want it to do. So we're going to give this a try. Okay, for number 1, A and B, we're going to do this one quickly because this one should become quite simple to you because you've been doing this in geometry as well last year. We want to find the sine, cosine, tangent, cosecant, secant, and cotangent of this triangle. First thing we need to do is we need to find the third side of the triangle. We're going to do that by doing the Pythagorean Theorem. So 15 squared plus x squared equals 17 squared. See, this is what I'm saying. What is this? Okay, sure. Oh, great. It just closed my file. Oh, Lord. Okay, here we come. It's back. So we have 15 squared plus x squared equals 17 squared. I'm not going to do all the math with you. I'm going to have you do it on your own. X equals 8. Then we need to set up our sine, cosine, tangent, cosecant, secant, and cotangents. Sine is going to be 8 over 17. Cosine will be 15 over 17. Tangent is 8 over 15. And then we just do the reciprocal of those. Cosecant then would be 17 over 8. Secant would be 17 over 15. And cotangent would be 15 over 8. Okay, very similar on the second problem, part B, but we need to make sure we simplify as we do this. So we have 10 squared plus 16 squared equals x squared. You're going to end up with x equals 2 root 89. And we want answers in simplified radical form. If you give me a decimal, it is wrong. So we like to keep it in radical form, so it's 2 root 89. So our sine is going to be 10 over 2 root 89, which we don't like that. We need to simplify the 10 and the 2, first of all, becoming a 1 and a 5. And then we don't like the radical on the bottom either. So we got to get rid of the radical by multiplying the top and the bottom by root 89. So we end up with 5 root 89 over 89. Cosine is very similar. It's going to simplify to be 8 root 89 over 89. And the tangent is going to simplify to be 5 over 8. You're going to do the reciprocal of each of these. So cosecant is going to be the square root of 89 over 5. Secant is the square root of 89 over 8, and the cotangent is 8 over 5. Okay, number 2, solve a right triangle, ABC, that has leg A equals 42, and the measure of angle B is 34. And we want to find all the other parts of the triangle. Well, right away, we know that B is not the right angle because they tell us that angle B is 34. So just name one of the other angles, angle B, and fill in your chart. That also means little b is going to be opposite of that. We then are told that A is a leg, which means it cannot be the hypotenuse, so A has to be the other leg, which means angle A has to be across opposite from that, which leaves C to be the right angle and the hypotenuse. So now we just fill in all the other information. We know that C is 90 degrees, which means that A has to be 56 degrees because they all have to add up to be 180. We're also told that little a is 42. And then we're going to set up some trig functions to find B and C. To find B, we're going to do the tangent of 34 degrees is going to be B over 42. And you're going to get out 28.33 as our answer. Little c, we're going to use cosine, so we're going to do the cosine of 34 equals 42 over c. We're going to work that out, and c is going to get us to be 50.66. Okay, for number 3, same sort of thing. We have another right triangle. Sort of a right triangle there. We are told this time that the hypotenuse is M. So this is M and it's 13. So that means the right angle has to be angle M. And then we were told that angle S is 18. So it can be either angle, it doesn't matter. And then angle H will have to be the other side. And then we fill in our chart. Little m is 13. Big M is 90 degrees. Little s is 18 degrees. So that means, big S is 18 degrees. That means H has to be 72 degrees. You're going to set up trig functions again, and you're going to get H to be 12.36 and little s to be 4.02. Number 4. There we go. The angle of elevation from the bottom of the lift to the top of the snow bowl is 33 degrees. If a skier rides 1,000 feet on this lift to the top, what is the vertical distance between the bottom of the lift and the top? So we're going to draw a little picture here. This is my mountain. Kind of scary with those spikes in there, but it's a mountain. Here's a skier on a ski lift, the little gondola thing that they ride. We were told that the skier rides 1,000 feet on this lift, and that the angle of elevation is 33 degrees. And we want to know what is the height, vertical distance between the bottom of the lift and the top. So we want to find the height here. So it's just going to be a trig function. We're going to set up sine of 33 equals x over 1,000. X mean is going to equal 544.64 feet. Number 5. All right, number 5. The angle of depression of an aircraft carrier from an approaching airplane is 52 degrees. If the plane is 700 feet above the level of the deck of the carrier, how far away is the carrier? So an aircraft carrier is a boat. And then we have an airplane. There we go. The plane is 700 feet above the level of the deck. So that means this here is 700. How far away is the carrier? We have also the angle of depression is this angle right here. That's 52 degrees. That is congruent to this because they're alternate interior angles of parallel lines. So that also is 52 degrees. And we want to find out how far away it is. So we want to find this distance here. So we're going to set up a trig function that the tangent of 52 equals 700 over x. Solve that, and x equals 546.9 feet. Okay, number 6. Ooh. Told you, technology does not like me. We're just going to go with this and erase it. Okay. Tom and Dakota are on opposite sides of a tower of 140 meters height. So this is going to be my tower. The tower is 140 meters height. Tom will be over here. Dakota will be on the right. Although it really doesn't matter which side each of them is on. They measure the angle of elevation on the top of the tower as 46 degrees and 60 degrees respectively. That means 46 degrees goes with the first one named. So Tom is at 46 degrees elevation. And then Dakota is at 60. We want to find the distance between, Tom and Sam. I forgot to change that one to Dakota. Dakota. Okay, so we want to find this distance. All right, so we need to use a trig function here to find Tom's distance away from the tower. We're going to use the tangent. So tangent of 46 equals 140 over x. So we get x to be 135.2 feet. We're going to do the exact same thing for Dakota. We're going to get that Dakota's is 80.83 feet. So you add those together, the 135.2 and the 80.83, to get the distance across to be 216 feet. And that is your answer. Okay, number 7. I know I'm going fast. I'm trying to go fast anyways, but this is a long review, so we have a lot to do. Okay, convert from degrees to radians. All you're going to do on this one is you're going to multiply by pi over 180 for each of these. This is all calculator work. Put 330 over 180 in your calculator and hit math, enter, enter. And it will simplify it for you to be 11 over 6. And then just add the pi back in. So 11 pi over 6. Second one's going to be 2 pi over 5. Letter C is going to be negative 25 pi. Here we go again. Okay, here we go again. So this is going to end up being negative 25 pi over 18. And then the last one, if you multiply by pi over 180, you're going to end up with 4 pi over 5. Okay, number 8 is very similar, except this time we're going from radians and then back to degrees. So we're going to take each of these and we're going to multiply it by the reciprocal of this. So 180 over pi. When you do this, your pi's are going to cancel out. Yay. And then again, it's just calculator work. 5 times 180 and then divided by 6, we end up with 150 degrees. Doing the same thing for B is 86.4 degrees. C is 600 degrees. And D is negative 160 degrees. Excuse me. Okay, number 9, find the arc length of a sector with the given radius and a central angle theta. This is your formula, S equals R times theta. We will give that to you on your test. But this is the part you need to remember, because this is not going to be on the test. You need to remember, you have to switch this theta, this degrees, it has to be in radians. If it is not in radians, you will not get the correct answer. So we need to first do that. So we're going to take 32, multiply it by pi over 180, and then we're going to get out 8 pi over 45. So then we're going to plug it in the formula. So S equals, our radius is 18 times 8 pi over 45. You're going to multiply all that out. You're going to get the arc length to be 10.05 inches. You're going to do the same thing for B. You need to convert that 136 degrees to be radians, so pi over 180. That simplifies to be 34 pi over 45. So you're going to take that times 4.3, and you're going to get an answer of 10.2 yards. Number 10, find the area of a sector with a given radius and a central angle. Theta, that should have theta there, sorry about that. Again, your formula is A equals 1/2 R squared theta. And again, you need to make sure it's in radians. If it's not in radians, you cannot do the problem. I use the same exact dimensions that we did up here in A, so I've already converted it here. So we have 1/2 times the radius, which is 18 squared, times our theta version, which was 8 pi over 45. You multiply all that together, and you end up with 90.43 inches squared. For part B, you have 1/2 times 4.3 squared times our theta version, 34 pi over 45, and you end up with an area of 21.93 yards squared. Okay, number 11. McHenry Pizza sells 12-inch and 16-inch diameter pizzas. They cut the 12-inch pizza into 6 slices and the 16-inch pizza into 8 slices. Would you get more pizza selecting 3 slices of the 12-inch pizza or 2 slices of the 16-inch pizza, and then explain? So we need to find out the area of a slice of the 12-inch and an area of the slice of the 16-inch. So I'm going to organize my work I can follow it, and that way anyone who's watching it can follow it. This is advice from a teacher giving you to a student. Organize your work so it looks pretty and I can follow it. Okay, first thing is we need to find out what our theta is. We need to find our central angle. So we have a pizza that's divvied up into 6 pieces. Ooh, that's not that bad. Not really a circle, more of a oblong thing, but whatever. Okay, so we take 360 degrees divided by the 6 slices we have. That means the central angle of each of those is 60 degrees. Now, this is one you should have memorized, putting it into radians. You shouldn't have to convert it. You should automatically know that this is pi over 3. Then you're going to plug it into the formula that we just used previously. So we have 1/2. Now be careful here. We want the radius. We are given the diameter, so you need to cut that in half. So 6 squared, and then times pi over 3. You're going to get 18.84 there. But remember, we want 3 slices of the 12-inch pizza. So you're going to multiply that by 3, and you're going to end up with 56.52 inches squared. Okay, now for the 16-inch, same thing. We have a circle divvied up into 8 slices. So we take 360 divided by 8 to find our central angle there to be 45. This is another one that you should have memorized, so you don't need to convert it, that this is pi over 4. Then we plug it into our formula, 1/2. Again, remembering that we need to find the diameter, or the radius instead of the diameter, so it's 8 squared times our theta of pi over 4. We multiply all that out, get 25.12, and we want 2 slices of the 16-inch. So multiply that by 2, and then we end up with the answer of 50.24 inches squared. And so, would you get more pizza selecting the 3 slices of the 12-inch or the 2 slices of the 16-inch? Well, the area is bigger of the 3 slices of the 12-inch, so that's where you would get more pizza. There you go. Number 12. The beam from a lighthouse on the east coast reaches a distance of 8 kilometers and spreads to an angle of 35 degrees. The beam from a lighthouse on the west coast reaches a distance of 6 kilometers and spreads to an angle of 44 degrees. Which one covers more area? What would the people at the west coast lighthouse have to change the radius to be, keeping the same angle, in order for the 2 lighthouses to cover the same area? Well, first thing we need to do is find the area of each of them. So again, I'm going to nicely organize my work so the person grading it can follow the work. Again, word of advice. So east and west coast. So east coast, we're going to use our area formula, 1/2. Our radius is 8 squared, and we need to convert our 35 degrees into radians. That's going to be 7 pi over 36. That gives us an area on the east coast that it covers of 19.54 kilometers squared. We're going to do the same thing for the west coast. We're going to have 1/2. Our radius this time around is 6 kilometers, so 6 squared, and an angle of 44, so we need to convert the 44 degrees. And we convert that, and it is 11 pi all over 45. Multiply all that out, and we get 13.816. I'd give anything to make a man of mine. 13.816 kilometers squared. So who has more area? Well, east has more area. So that is one of your answers. Then it asks, what would the people at the West Coast Lighthouse have to change the radius to be, keeping the same angle in order for the 2 lighthouses to cover the same area? So that means we need to change the west, so that means it needs to equal the east. So we're going to do 19.54 equals 1/2. This time we're changing the radius. We don't know what it is, so it's going to be r squared. But we want the angle to be the same, so that's going to be 11 pi over 45. So So we have 19.54, and then we just work this out, solving for r squared. 11 pi over 45 is 0.768. I'm running out of room here. And then we multiply 0.768 times 1/2. Divide by that on both sides. We're going to end up with 50.89 equals r squared. Square root both sides. And r equals 7.13 kilometers. And that would have to be the radius of the west coast in order to solve that or to get the same area. Okay, target 3, which is, I know, the fun part we've all been waiting for. Let me erase this part here. Okay, evaluate the function without using a calculator. Give exact answers. That means we do not want decimals. We need to keep things in roots. If it is a quadrantal angle, which means a multiple of 90, so 0, 90, 180, 270, 360, and so on, then just give the answer. All other angles follow these steps. So tangent of 270. So 270 is straight down. And tangent is opposite over the adjacent. Well, oh, man almighty. Here's pause again. Okay, we're going to try this again. So 270 degrees is straight down. So we want opposite over the adjacent. The opposite, this is your y value, so it's -1. The adjacent, there's no back and forth at all. It's not moving at all upon the x-axis, so that would be 0. And anything divided by 0 is? Yep, that's right. Undefined. Okay, cosine of 210. For the cosine of 210, we first need to find out what quadrant we're going to be in. 210 is past 180, so we're going to end up here in the third quadrant. The reference angle, how far past 180 did we go? We went 30 past 180. So we're going to make a triangle here. We want the cosine, so this is 30 degrees. Again, you should know your 30, 60, 90, right triangles. Across from the 30 is a 1, across from the 60 is a √3, and across from the 90 is a 2. So the cosine of that is adjacent over hypotenuse, so √3 over 2. Then we do the all students take calculus. All students take calculus. So this tells us that tangent is positive in the third quadrant, but we got a cosine. So that means our answer has to be negative. So negative √3 over 2. Okay, so the cosecant of -330. So we're going to go backwards. That means we're going to go down and around, -330. We're going to end up here in the first quadrant. Our reference angle, how far away are we from making a full circle? Well, we are 30 degrees away here. So again, we set up our 30, 60, 90 triangle. Across from the 30 is a 1. Across from the 60 is a √3. Across from the 90 is a 2. This is cosecant, which is the reciprocal of sine. So we need to find the sine of it. The sine would be opposite over hypotenuse, so 1 over 2. We want the reciprocal of that, so it's going to be 2 over 1. We're in the first quadrant. Everything's positive in the first quadrant, so our answer is positive, so our answer is just 2. Last one, we have cotangent of 225 degrees. That means we are going to be going into the third quadrant. How far away are we from 180? We bypassed 180, went around, and we are 45 degrees away from 180. So we set up our 45, 45, 90 triangle that we should know, where the legs are both 1, hypotenuse is √2. We want the cotangent, which is the reciprocal of tangent. So tangent would be 1 over 1. We flip that, and guess what we get? Yep, that's right, 1 over 1. So it's still a 1. We are in the third quadrant. All students take calculus. So the tangents and cotangents are positive in the third quadrant. So our answer is a positive 1. Okay, we're going to do the same thing here but in terms of pi for number 14. The same type of process. And again, because you guys are going into pre-calc next year, they're going to assume you know these pi symbols. So I do not want you converting them to degrees. I want you to keep them in terms of pi. It will help you next year. So 2 pi over 3. You ask yourself, if you want to set up your, this is 0 and 2 pi. Over here, this is pi. Up above is pi over 2. Because that's halfway between the 1 pi and 0. Down below, in between 1 and 2 pi, is 3/2 pi. Feel free to do that if you need to or if you want to do that. So then we ask ourselves our question, this 2 pi over 3. Again, don't worry about the pi right now, just look at the number. So we have 2/3. Is that greater than or less than 1? Well, 2/3 is less than 1. So that means we don't yet hit this pi symbol here, so that means we're going to be in the first or second quadrant. Then you have to ask yourself, is it greater than or less than 1/2? So we know whether or not we cross the 90. Well, it's greater than 1/2, so that means we've bypassed the 90 degrees, but not hit the 180, so we are here in the second quadrant. We need to find our reference angle. So how much do we need from 2/3 in order to get a full pi? Well, we are short 1 piece of pi. So pi over 3. Pi over 3 is just the same thing as 60 degrees. So across from the pi over 3 would be the root 3. And we have 1 and 2. We want the sine of this. So the sine of this is going to be root 3 over 2. And is it positive or negative? It's all students. It's a sine, so it is a positive being there in the second quadrant. Okay, letter B. We have the secant of 11 pi over 6. 11 pi over 6 is greater than 1 pi. So then we ask ourselves, is it greater than or less than 3 pi over 2, 1.5? It's greater than that even, so it's going to be over here in the fourth quadrant. So then we ask ourselves, how far away is it from making 2 pi? Because we're at the 360 degrees, which is 2 pi in radians. So how close are we to making a 2 with the 11 over 6? Well, we're really close. We just need one more. So we have one more piece of pi over 6. And that is our reference angle. Pi over 6 is the same thing as 30 degrees. Again, one of those you should automatically know. So across from that is the 1. And then we have root 3. And then 2. We want the secant. Secant is the reciprocal of cosine. The cosine would be root 3 over 2. We want the reciprocal of that, so it's going to be 2 over root 3. Then is it positive or negative? It's with cosine. All students take calculus. Cosine's positive there, so our answer is positive. But we still don't have the right answer. We need to rationalize the denominator. So we're going to multiply the top and the bottom by root 3. So we're going to end up with 2 root 3 over 3 as our answer. Third one, cosine of 9 pi over 2. I know right away that 9 pi over 2 is bigger than 2, so it's going to be over a full circle. So I'm going to subtract off 2 pi. If I subtract off 2 pi, I have 5 pi over 2. That's still bigger than a circle. That's bigger than 2. So I'm going to subtract off 2 pi again, and I end up with pi over 2. And pi over 2 should be one of the ones you have memorized. It's straight up and down. It's the 90 degrees. We want the cosine of this. So cosine is adjacent over hypotenuse. There is no adjacent. There is no back and forth at all. It's only up and down. So that is going to be 0 over 1, which is 0. And then the last one, tangent of negative 5 pi over 4. This time we're going backwards. We're going clockwise on this one. So 5 over 4, is that greater than or less than 1? It's greater than, so that means we're going to pass the pi and go into the next one. Man! Okay. Each time it does this, it's nothing on the video, but for me it takes like 3 minutes in order to get back to doing this. So. Okay, so we're past the pi marks. We're going to go into the next one. We're going to end up being here in the second quadrant. How much further past pi did we go? Well, a full pi is 4 over 4. We went 5 over 4, so we went 1 pi past it, so pi over 4. That is a 45, 45, 90. Again, one of the triangles you should have memorized. So this is a 1, 1, root 2. Tangent is 1 over 1. Is tangent positive or negative in the second quadrant? It is negative, so our answer is negative 1. Okay, number 15. A fire truck has a ladder that can extend to be 105 feet long. If the base of the ladder is 12 feet off the ground, how high can the ladder reach on a building if it is extended at a degree of 65 degrees? So first, I like to draw pictures, even though I'm bad at it. I should have done it in red. That would have made more sense, Miss Teal. Get with it. Okay, so our ladder is going to come off at this point. Our ladder is 105 feet long. We have this building on fire over here. And we want to find out how high our ladder can reach on top of the building. You also have to take into account that it's already 12 feet off the ground. So this 12 is here. So that's going to come into play at the end of this. Okay, so our degree is 65. And we want to find this height here. So we're just going to use a trig function. We're going to use sine. So the sine of 65 equals x over 105. Finding x to be 95.16. Then we got to take into account this 12. So we're going to add 12 to it. And we're going to end up with 107.16 feet. That's how high up the building our ladder can reach. Okay, number 16 is going to be very similar to this problem. And there's one exactly like this on your test. The Navy Pier Ferris wheel has a diameter of 140 feet and its base is 10 feet off the ground. You board a gondola on the Ferris wheel and, well, rotate 158 degrees counterclockwise before the wheel temporarily stops. How high above the ground are you when the wheel stops? So again, get to draw a picture. So here's the base. That is 10 feet high. Here's our Ferris wheel. The radius of the Ferris wheel is 70 feet. Now, we are going to load the Ferris wheel at the bottom here. And then we're going to go counterclockwise 158 degrees. So here's 90 degrees, and then we're going to get up here. This here is 70, that's our radius. We need to find our angle here. And our angle there is 68 degrees. And then we want to find the x. We want to find out the actual height that we have gone in that section of the circle. So again, we're going to use a trig function. We're going to use sine again. So the sine of 68 equals x over 70. We're going to multiply that out, and we're going to get x to be 64.9. But it's asking for the total height that we are above the ground. So this is 64.9. This is 70 because it's the radius of the Ferris wheel, and we've gone that far up. And then we got the 10 on the base there. So we're going to add them all together, and we get 145 feet. So that is how far we are off the ground. Okay, Ryan Sandberg hits a baseball at an angle of 29 degrees and at a speed of 110 feet per second. If the ivy at Wrigley Field, if you don't know, Ryan Sandberg is a famous Cubs baseball player, and left field is 355 feet away, and that is where the ball is headed, does Sandberg get a home run? We give you the formula, and we'll give you the formula on the test tomorrow. So we have D equals, our velocity is 110. squared over 32 times the sine of 2 times theta, and theta is 29 degrees. You do all the math with that, and we get a distance of 320.67 feet. So we need to get 355 feet to get a home run. So does he get a home run? No, he doesn't get a home run. Okay, and then target 4. That overall you guys did quite well on the quiz on this one. Evaluate the expression without using a calculator in both radians and degrees. Follow the following steps. State the quadrant, state plus or minus, state the reference angle. Okay, so cosine of 1/2. So we need to find out what angle that's talking about. Cosine is positive in the first quadrant, so we're going to draw it in the first quadrant. It's cosine, which is adjacent over hypotenuse, so 1 over 2, which means this is, oh, yeah, guess what? It's one you know. This is root 3. So that means this is a 60-degree angle. And since we're in the first quadrant, that just stays as our answer. So 60 degrees, and you should automatically know that 60 degrees is pi over 3 in radians. Letter B. Cosine is negative root 2 over 2. You should be able to recognize that this is a rationalized denominator, that this really means negative 1 over root 2. Cosine is negative in the second quadrant. Cosine is adjacent over the hypotenuse. So what one does this remind us of? This reminds us of a 45-degree angle. So our actual angle here is 135 degrees because that's how far we have come from the 0 degrees. So it's 135 degrees. And then we convert that to radians. So radians is 3 pi over 4. Okay, the sine of root 3 over 2. Sine is positive in the first quadrant. Sine is opposite over hypotenuse, so the opposite is root 3. The hypotenuse is 2. That reminds us of, oh yes, that is a 60-degree angle as well. So this is 60 degrees and pi over 3 again. And then the last one, we have the tangent of negative root 3. Tangent is negative in the fourth quadrant. Tangent is opposite over adjacent, so the opposite is root 3. The adjacent is 1. So this is, oh, looky there, yet again, a 60-degree angle. So this is 60 degrees. So our actual angle this time, because we want to know how far away around we completely went around the circle, is 300 degrees. And converting that to radians is 5 pi over 3. Almost done, people. Almost done. Number 19. Cosine of theta equals 0.38, and we want our answer to be in between 270 and 360. So which quadrant is between 270 and 360? That's the fourth one here, so we're going to draw our triangle here in the fourth one. This is just a plugging in your calculator. You're going to do second cosine in your calculator of 0.38. You're going to end up with theta being 67.67 degrees. So we want to find out what actual angle that is. So you're going to take 360 because we didn't quite make it all the way around the circle. We're 67 degrees short. So you're going to take 360 minus the 67.67 and we're going to get 292.33 degrees. Yay, here we go. Okay, and we're back. So 19b, we want the tangent of theta equals negative 8.5, and we want this between the 90 and 180. So between 90 and 180, that means we're going to be in the second quadrant. You do in your calculator second tangent, and you get theta to become 83.29. So we are in the second quadrant, so we don't quite make it all the way to 180. So we're going to do 180 minus theta to get our answer of 96.71 degrees. Number 20 and 21 are both have to do with this picture here. Yeah. Oh, that's frustrating. Oh, for the love. Okay, we're just going to leave it as that. Different types of granular substances naturally settle at different angles when stored in cone-shaped piles. The angle theta is called the angle of repose. When ashes are stored in a cone-shaped pile 8 feet high, in here I changed it from the sheet you have. I told you in class, but I changed it on here. The radius of the pile's base, I couldn't read last night when I was doing this. The radius of the pile's base is about 9.53 feet. So that means right here is 9.53. It is 8 feet high. We want to find out what is the angle of repose for ashes. So this is just a straight up trig question. This is the tangent of theta equals 8 over 9.53. And you get, again, you're trying to find the angle, so make sure you use secant tangent. And you get theta to be 40 degrees. There you go. Number 21, when dry sand is stored in a cone-shaped pile, it has an angle of repose of 34 degrees. If a pile of sand is 10 feet tall, what is the diameter of the base? I'm going to erase my markings the first time around. This time, we are told the angle of repose is 34 degrees, and a pile of sand is 10 feet tall. We want to find out the diameter, but in order to find the diameter, we need to find the radius first. So again, we're going to use tangent function. So the tangent of 34 equals 10 over x. Multiply both sides by x. Divide by tangent of 34. So 10 divided by the tangent of 34 gives us x to be 14.83. But again, that's the radius. We're asking for the diameter. So you're going to multiply that by 2. And the diameter is 29.66 feet. And there you go. If you want to see any of the answers here, here are the answers. And there you go. Good luck on the quiz on the test tomorrow.